All right. Yeah, I gotta have to be say the truth. Even though I'm solving the today Leetcode problem, that is literally the yesterday Leetcode problem already, since I've passed the 2 hours, and yeah, I don't want to miss any Leetcode today's question. So I was rewind back my timeline and I'm trying to solve the problem. So the Leetcode problem is a minimum number of operation to make all arrays elements equal to 1. So what we given is a zero index array consisting of all the positive integer, and then we can do the following operation on our array at any number of time. So we have selected the one index such as within the 0 to the count -1, since it is a zero-based index, and now we replace either of the number of I or number of I plus 1 with their GCD value. So GCD in here mean like greatest common divisor, not the grand central dispatch from the iOS. And we have to return the minimum number of operations to make all elements of nums equal to 1. So if it's impossible, return the -1. So the GCD of two integers is the greatest common divisor of the two integers. So if I have to explain about the greatest common divisor, okay, let's run through the HTML 1. So in HTML 1, we are given the 4 integers, which are 2, 6, 3, and 4. In here. So every time we have selected the index, we can only include the index of I plus 1. That means the element right next to our selected index. So let's say we have selected the index 2, which is 3. And then the index next right to the index 2 is index 3, which is 3 and 4. So we're going to search what is the GCD of 3 and 4. And then the GCD of 3 and 4 is 1, since 1 is the greatest common divisor for the 3 and 4. So if we got the 3 greatest common divisor, we're going to replace the minimum value with our greatest common divisors. So after we replace the greatest common divisor, since the 1 is the greatest common divisor on most of the all positive integers, so we can have a replace our greatest common divisor by choosing the index 1. And then GCD of 6 and 1 is 1, so we replace 6 with a 1. After that, we're going to replace the index 0 by selecting the index 0 and 1 as a sub-array, and then we replace with our greatest common divisor. Last but not least, this is a last index, and then we check the last index and then last index -1. So we have everything to become the number of 1, and the total number of operation is the 4. That's why we got the 4s in here. So if I have to run through the next assignment 2 in here, let's say we check the greatest common divisor. Let's consider we are choosing the number of 1, which is 10. Let's choose like index 0. There's a 2 and 10. What is the greatest common divisor of the 2 and 10, which is 2. So we got a 2, that's still not 1. So after we update our greatest common divisor for assignment 2, that will be 2, 2, 6, and 14. So we go through, then we're going to check like index number of 2, which will begin 2 and 6, which is a 2 and 6 in here. So if we check the 2 and 6, our greatest common divisor will become the 2 in here. So it's a triple 2 and 14. The same if we check the last index. So the greatest common divisor of the 14 is also the 2. So we have all 2. And yeah, we never got the 1 in greatest common divisor. So that's why it is returning the -1 in our case. So let's go ahead and try to solve the main problem. The same as the previous one, I'm always going to create the count by using the nums.count, since I don't want to calculate the counts every time I iterate it through. And then I'm going to calculate, since the constraint of the number is the numbers of the each element could be between the 1 to 10 power 6, which means it's 1 to 100k, 100,000. So what we're going to do is I will have one variable that to keep track of the how many ones include in the given index array. Let's call like x in nums, or we can just filter like, okay, just write simple x in num. And if x is equal to 1, we are going to plus 1 to the 1, and then we will check like if 1 is greater than 0, we just return the n dash 1, since we have a 1 values in our given integers, and then we just detect the remaining integers. So that's the answer for us. Next is I want to find the shortest subarray with the greatest common divisor, which is equal to 1. Let's consider like best length. I'm going to use maximizing the integer values in here, since we don't want to narrow down our subarray contexts. So let's go through for index in 0 through count. So we're just going from the 0 to the last index of the given numbers array. And then we're going to, let's call like G for the initial of the greatest common divisor. So which is selected, and then I'm going to choose the index. So let's call like we start from index 0. And then how I'm going to do is there could be another J. Let's call like subarray, and then which will be the index plus 1, since we don't want to narrow down the scope. So the minimum of the subarray is from 2, so we just plus 1 to the index through the count. And then in here need to check the GCD. Right, I think we need to create the separate fashion for GCD, since we are using the GCD. In that case, let's call like private fashion. Let's call GCD of A and B. We just return the remaining for the GCD. So what the GCD is, since we don't want to use memory address in here, I will just create the variable for A and B so that we can play around with the variable in here. So if B is not equal to 0, that means that second subarray index is not 0. So what we're going to do is we're going to update the A by using the remainder of the B. So and then we can swap the between A and B with the B and A, and then we just return A. Yep. So after have a GCD method, we can use inside here by let's call like updating the GCD G with GCD and the nums of subarray. So if our initial GCD value is 1, what are we going to do is we can simply calculate the length by detecting the subarray minus index plus 1. So that will be the best value because we get the 1 GCD values. So after that, we can just detect from all the possible array. Yep. So that is just to update our length with the best length. So another thing we can check, if best length is stay equal to the max, we just return the -1. Wait, I think we need a one break in here. So after we check in here, just return -1 here, and then we got the GCD, just -1. okay, I make a mistake here. So I think I have to check the length is greater than best length in here. So if the best length is greater than for sure, that means we have like maximizing the positive integer. Then if the length is smaller, then we replace the best length with our length. Let's try to run it out. And what did I do wrong? Oh, I'm missing the in for loop. Alright, what did I do wrong again in line number? Oh, silly me. Should be inside the function. And then I still need to return the result by detecting the -1 to best length plus our count of array -1. What did I do wrong? Okay, it should be the plural ones. Sorry guys for making a lot of typo in submission. Wait, how come I type like n? Next time I should use the number of array counts as n. Alright, I think in that case the time complexity will be the O of n squared and the space complexity will be the O of n. Let's check it out. Yeah, O of 1 since we don't use the extra space for the time complexity, since we have a nested for loop in here that will make us the O of n squared. Right, that's pretty much for it, and see you in the next video. Bye.